Hi, I'm Jim Lake. My friend Paul and I have decided to build an Lockheed S3 Viking. The S3, affectionately known as Hoover by its Navy crews, was a fixture in naval aviation from the 80s until just a few years ago when the Navy decided to retire it. The Viking's primary job was anti-submarine warfare, but it also performed many other jobs in the fleet, from aerial tanker to expediter. The S3 we will build will be 1/9 scale. From the beginning, we knew that the biggest problem we would face would be the landing gear. The S3's main landing gear has a very wide stance with huge oleo struts intended to handle landing loads on the carrier. The gear retracts rearward into the gear well. We needed a pneumatically actuated 1/9 scale gear implementation, and, of course, it was not commercially available. So we decided to make it. We were able to borrow a set of A7 gear of similar size to see how it was made. Unfortunately, it retracts forward, but the operating principles were similar to what we needed. At this scale, the S3 gear is 18 inches wide when extended. When retracted, it and its 3.5-inch wheels had to fit in a very confined space. It needed to rotate a full 90 degrees and lock in both the up and the down position. We tried several different designs, but the actuator tended to interfere either with the gear strut or with the actuator on the opposite side of the airplane. One of the thornier problems we had was finding a source for a pneumatic actuator with the correct stroke. You would think these would be readily available in the US, but they're not. I finally found one from a Chinese supplier in the right size, and I was quite pleased with the price and the quality. Finally, we settled on a design in which the pneumatic cylinder is parallel with the center line of the aircraft. It pulls up and down on a lever that turns a center shaft connected to the main gear strut. When the gear retracts, the main and oleo struts lie just next to the actuator inside the gear well. A locking slot on the top and bottom lock the gear up and down. We made a mock-up of the aircraft to test the landing gear before we made the fuselage of the airplane. That way we could be sure the gear would work correctly when installed in the airplane. Okay, so the video is rolling, so go ahead and cycle it on up. And down. How much pressure have we got there, Paul?
Oh, we got about 80 pounds.
Oh, this is a long cylinder with a lot of.
Well, I got it turned way down.
Well, actually, I like that speed myself.
Well, that's fine. I mean, all we got to do is put a couple of those little brass valves in the system, and they'll take care of that.
Okay. Let me get this from another perspective here.
Okay.
All right, go ahead and give it a shot again.
You want it to work a little faster?
I tried a little faster, yeah.
I like the slower speed better.
Yeah, that's a little bit too fast. Okay, I like it. One other problem that we've got here is that this right now, the inside bottom edge of the wheel is about a quarter of an inch below the bottom of this point now.
Now, we can move the gear up just a little bit too.
Yeah, we're gonna have to move it up. Actually, I wanted to move it down a little bit, but.
Well,
Now, how much, we've got 3/16 on the outside of this, don't we?
we do. We do. You could put a shim under this side. You know,
I could, but I
put-
don't want to, because remember, there's gonna be a plate that goes all the way
Yeah.
across this whole thing that holds both gear.
But that's fucking awesome.
Yeah, it
That
is.
works great. That's just as good as we could have expected.
Yeah, that's good.
Yeah.